Good afternoon, everyone. Thank you for attending Session 6 of the IBR Webinar series. As a reminder to all participants, this webinar is public and is being recorded. The registration information was posted on the NERC website and widely distributed. Speakers on the call should keep in mind that the listening audience may include members of the press and representatives of various governmental authorities, in addition to the expected participation by industry stakeholders. Should you wish to ask a question during today's webinar, please use the Q&A feature. It is NERC's policy and practice to obey the antitrust laws and to avoid all conduct that unreasonably restrains competition. This policy requires the avoidance of any conduct that violates or that might appear to violate the antitrust laws. Any NERC participant that is uncertain about the legal ramifications of a particular course of conduct or who has doubts or concerns about whether or not NERC's antitrust compliance is implicated in any situation should contact NERC's General Counsel immediately. At this time, we'll hear a few words from Alex Shattuck.
Thanks, Levitra. Try to keep it to a couple words here. There's a lot of good content here today. So welcome. This is session 6. This is modeling part 2. So if you all caught modeling part 1, this is a good logical follow-on to it. What we're going to do today is we're going to talk about model quality metrics from ERCOT. We're going to talk about model benchmarking and kind of model philosophy from Vestas, and we have a Prashant from Tesla here who's going to talk about their models and that kind of stuff as well. So following up with the other 2 presentations. So this should be a lot of good content. I want to make sure we have plenty of time for questions and presentations. So without saying too many more things, oh yes, just one more thing. If you have questions, use the Q&A. Just to reiterate, we're going to take those questions and do themes of them and post them along with the meeting materials once the series is over. So please put those questions in there. Even if we don't get to them, all of them later, they'll be answered at some point. So I guess with that, we'll move right on. Jonathan, you're up.
Okay, thank you. Good afternoon, everyone. This is Jonathan Rose. I work at ERCOT in transmission planning, and I just want to say this has been a really great series. So I want to extend my thanks to Alex and Avetra and all the staff and all the people who presented so far. So today I want to give a little bit about our perspective of modeling at ERCOT from an ISO. And specifically, I want to answer or try and answer 2 questions. As an ISO, how can we ensure that the models have good performance and are accurate? How can we ensure performance and accuracy? Next slide. So to try and achieve this goal, we've developed this process, which we implemented in 2020 and expanded in 2021. This is a process with 4 facets to help ensure model quality, accuracy, and performance. Starting with the top, we have model quality tests. So ERCOT, we require when a generator owner submits a model to us, they must provide a model quality test report. They can't just submit a model, but they must provide a report demonstrating to us the model performance. So they must submit a report with their model showing good performance and also to show that the PSSE and PSCAD and TSAT models match. We require those models. Moving on to the right, parameter verification. This is another requirement we have to check that the model parameters match the field settings, and this augments the NERC mod 2627 tests. Down below, we have the unit model validation, and this is basically the type test. These are the hardware benchmarks that we require to ensure that the PSCAD models are structurally correct. And then finally, on the left, we have disturbance benchmarking. These are the event analysis to check what actually happened and did the models predict performance. This process is described in our model quality guide. So if you're interested to learn more, it's a very user-friendly document and it is linked to there on our slide. So I'll talk about each one of these on the next couple of slides. Next slide. Unit model validation are hardware benchmarks, also called type tests, and others in industry. So the goal of this test is to ensure that the PS-CAD model is structurally correct. So before a plant interconnects, they must submit a report to us demonstrating that they perform a hardware benchmark of the PS-CAD model against an individual wind turbine or solar inverter. So this is to determine that the PS-CAD model is structurally correct. This does not have to be site specific. They can use default parameters, and we don't currently require them to test the full scale machine. They can just test a stripped down machine. They can test a control board and run the bulky components using hardware in the loop RTDS simulation. This is required before plants interconnect, and it has had some successes. We've seen cases where the PS-CAD models were not having the correct subsynchronous response, which is very important in ERCOT because we have a lot of series capacitors. And we have seen a few cases where they did not have the correct ride-through response. But for the most part, most PS-CAD models easily pass this benchmarking. And since it's not site-specific, an OEM will typically submit the same report to several sites if they use the same turbine or solar inverter. So this isn't site-specific, but the next slide, the next test, we'll get into the site-specific settings, the parameter verification. So this is where we ask site owners to submit a report where they demonstrate, they provide evidence that the model numbers match the equipment settings in the field. So for example, the generator exciter, let's say it has a gain of 5. Does the model also have a gain of 5? Show us that it matches. This augments the mod 2627 studies. Those studies are, test measurement based. This is a numerical comparison. And so this goes a lot further than the mod studies because those typically don't run, like fault response or large signal response. So they're kind of limited to what the mod studies can do for IBRs. They also don't typically check protection settings or exciter limiter settings. So this is where we get into more detail with this parameter verification. And this by far has been one of our most successful efforts. This year, we required all generators to submit verification reports. And a lot of them found that their models had at least one parameter that was not correct. They were checking the model parameters against, the protection settings in the field and whatnot, and they were found mismatched. So a lot of generators are having to update their models. IBRs, conventional thermal generators, they're having to update their models because of this exercise. So we found this very successful, and this was a lot easier to do than the event analysis, where you look at past events and you gather measurements and see how the models perform. Here we kind of did a one shot and found a lot of problems. So very successful effort. Next slide. So a quick note about generic models, and we've observed this sometimes, that I think everyone this makes sense and understands this, that generic models have limitations. The WCC generic models, they are simplified. And so we've seen cases where they cannot really be made to model the full PS-CAD model response, and hence the actual field response. And in many cases, the OEM, the user-defined model, does a better job. And at ERCOT, we've always been open to having user-defined models, and we have a lot of user-defined models. representing our IBR facilities. And they are both in PSSE and TSAT because we use both softwares, so they have to submit matching models for both softwares. Also, a quick note down at the bottom, we've noticed occasional differences on how generic models are implemented in different platforms. So you could take the same generic model with its parameters and you run in PSSE and PowerWorld and TSAT and PSLF, and you can actually get a different response. So they're not implemented exactly the same. There are small differences in wind-up limits and the way limiters and other details are done in those models. So just to be careful, be aware of that. Next slide. Model quality testing. So I mentioned this earlier. We require all generators, when they submit a model to us, they must submit a model quality test report. They must demonstrate to us their model behaves well. The tests are defined in the DWG procedure manual. This is our procedure manual document. For inverter-based resources, we define 7 tests. It includes voltage ride-through, voltage step tests, frequency step, short circuit ratio, and for PSCAD, also an angle step, an angle jump test. And we also have similar tests, a little bit different, but also have tests for synchronous plants. Our procedure manual also has example plots of what is a good and bad behavior. So when a generator owner does this test, they can see for themselves whether their plant is giving good or bad behavior before they ever submit the model to us. So this helps a lot in terms of the review process. They don't need us, ERCOT, to tell them, hey, your model, it's not performing well. They can run this test themselves and see for themselves it's not performing well before they submit the model to ERCOT. So this helps a lot. And to help with that effort, on the next slide, we provide 2 testing tools. We provide DMView for PSSE and PMView for PSCAD. So these are 2 testing tools that allow them to test their models and draw all these plots, run all these tests and draw these plots and produce these reports. And I encourage you all, if you're interested, to check these tools out. They're publicly posted. They're completely customizable. So if you want to change the VRT response to match whatever your region uses, it's a CSV input file. You can change what the tool runs. But they're pretty easy to use. That PSCAD test, it's just one block you drop at the POI, and it will run through all the tests with the multi-run block. It just cycles through, click run and go. And it will even run the new IEEE 2800 transient test. So we publish that. It's optional, but it helps a lot for generators producing these reports. Next slide. And so I'll wrap up just with a last note about Odessa. And we had a lot of solar plants trip. And a lot of these model requirements were coming into force when Odessa happened. So unfortunately, all those plants that tripped, they really weren't tested under these new model requirements. And I'm kind of hopeful that as we are rolling out these requirements, as the models are being updated and they're being reviewed with these new requirements, and the PSCAD models are being verified and they're checking, they're doing the VRT and the phase angle jump test, we will start to be able to catch some of the ride-through issues. Of course, this requires the plant owners and their consultants to make sure everything that needs to be modeled is modeled and all the relevant protection and so forth. So it's definitely a joint effort, but it can all be modeled and simulated. So I think we're on the right track here as far as the modeling, but it's definitely a continuous effort. So with that, I just want to wrap it up and just say thank you. I appreciate the participation.
Thanks, Jonathan. Perfectly on time. And we'll do questions at the end. So very good presentation. Really good to see all that laid out in this format. A lot of nice things in your presentation, and good to hear them coming from an ISO, certainly. So thank you very much. And with that, we're going to go on to Thomas from Vestas.
Hello, everyone. I'm Thomas from Vestas. I'm heading up our power plant solution groups, and we're supporting developers, utilities in North America from our group with everything related to grid compliance studies and modeling and so forth. Next question, or next slide. So this is we acknowledge that the industry, we have to look into the modeling, and also that as in relation to Jonathan's presentation, we have a lot of customer engagement very early on where they might not have chosen the supplier yet. So how to support the right simulation models for ISOs, utilities, all the way through plus 20 years. As we see in the industry, there's changes, new requirements, and models have to be updated, simulation tools. So it's something we need to look into as an OEM. And also we have as an OEM to appreciate and understand the push for these accurate models that we just also heard from Jonathan. From our perspective, and not only from, I think, from investors, but from an industry perspective, it's like inaccurate models means no connection and essentially no sales from an OEM perspective. So accuracy for the models and have tools and processes to prevent events like Odessa and similar is key for the industry. Next slide. So here's a question, and for you guys, and it's more like a reflection. I'll give a short answer on it later, but you're more than welcome to read it out. And it's like, how much do you think a power plant controller at plant level can impact current injection during a short circuit current study? And try to do some thoughts and thinking about that, specifically when we talk about short circuit studies today and how we look at IBRs. So I'll leave this cliffhanger for a bit and come back to that a bit later. Next slide. So why accurate models is needed, and why the great work done in ERCOT and other places in this industry is really appreciated. Here are two slides from actual wind farms that have been integrated in US from Vestas. On the left side, you see a generic model give a false negative. There's a huge oscillation that was imposed a transmission line upgrade on the developer to move this forward. Swapping that with a out-of-the-box user-defined model from Vestas, all the issues went away. So here it has a positive impact on the utility, on the developer, and also at Vestas, because it makes the project move forward with a more improved business case. So that's some of the challenges with generic models today, as Jonathan also alluded to. On the right side, it's not really a severe case. It's simply in the top plot, you have a voltage reference that is fed to a generic model that is tuned to do best match against the user-defined model with the exact same parameterization. And as you can see, over time, the response actually deviates, excuse me, in the response. And that's because there is a lot of differences in these models, and this is just a simple voltage reference change. We hear a lot in the industry that generic models is inaccurate around fault by true, it's small nuances, but here it's a voltage step change. And we are talking 5 to 10% difference in the reactive power response. For us, it's important to have transparency. Maybe the generic model is good enough for that study, but we need to create awareness of what is the engineering judgments that is being taken and be transparent with the performances. Next slide. In Vestas to overcome this is a bit of a busy slide, but on how our model development process looks like. We have looked a lot into the secret working groups and tried to adapt some of that work with model integration as well. So on the left side, we have kind of the product code. We transform that into a user-defined model. Those models can be called across different tools to minimize the risk and speed up the process to have same performances across different simulation models. That model also enables us, if there is an issue in the grid with regarding performance, we can actually take that back, use the user-defined models to improve the product code, and then close the loop and update hardware in the loop test as used in ERCOT. So having the models, we can actually have a very fast turnaround in the industry as an OEM supporting utilities with potentially stability issues that they would predict with the real products. So next slide. So having accurate models, and I want to emphasize it is possible, and this is not only for Vestas. We see a lot of OEMs put a lot of effort into this into industry. Here's just a few plots. The top corner is from an ERCOT MQT, where we have PSCAT, PSSE, and TSAT on top of each other for a voltage event, low voltage right through. The bottom corner is a mod test for frequency event on a site where the playback data is fed into the model and overlaid. In the top right corner, it's a different technology, but where we're comparing RMS and EMT models for the low voltage events, and also for different time steps, because we do acknowledge you need to have models running everything maybe in RMS from 1 to 10 milliseconds. So utilizing some of these great industry practices being worked on in NERC, but also SIGRE and others, we are capable as OEMs in the industry to have accurate models. Next slide. And so one of the challenging today is also a detailed model doesn't always necessarily mean an accurate model, and also what's being studied and what's being implemented on site. So on the right side, it's a fault right through event that is fed in. The expected behavior is the green curve you see on the right side, bottom side, where you see the reactive power injection. What actually was commissioned and installed at the site was the blue curve, and there is in this case I think 60 megawatt difference in the actual plant response. This is also why supporting ERCOT's parameter verification and performance is crucial throughout the process. Because if we do all the studies in the early Q phases, planning phases, stability phases, with all the models implemented in the grid, it's not accurate representative, we will see issues in the operational phase. So from planning to operation, we need to take a bit more accountability, I think from the OEM side as well, also to support that we provide the right and technical information for the right engineering judgments throughout the processes. Next slide. Now, coming back to the short circuit current answer, a power plant controller in our technology can impact for voltages in your short circuit studies more than 20%. So it's something we see when we talk about the CIR model, the VTCS models, and so forth, looking at IBRs. We often forget the outer loop plant controller, how important that can be for something just as a short circuit study. I don't want to go too much into this here, but also please feel free to reach out. We have some white papers that describe this more in details. Next slide. So from looking at also at Jonathan's presentation on ERCOT and the differences we just been through of accurate models, we think it's very important as an OEM that we support the industry across a project lifetime, but also across different phases from interconnection to the planning studies, to reliability studies, NERC compliance, continued model validation, have the user-defined models. So utilities always have the user-defined models on shelf to understand and be able to deep dive and do root cause analysis for certain events. Generic models might still have a case where they can use, but we do think it's important to have the right models and representative models for all scenarios to be studied. Next slide. So we all are aware about IEEE 2800 is coming, and are we prepared? And this is some of the questions. Do we know what we don't know? I think today, from our perspective, we see a lot of operational challenges on our assets that is not captured up front in the study phase. It's very time consuming, and it's imposing a huge risk on utilities if we are not having representative models across the phase, because when you have operational issues or find challenges, it's very expensive and time consuming for all parties. We also see if the risk of renewable assets causing reliability issues if we do poor tuning. So that's also where parameter reports and benchmarking we think comes in place to make sure we get the right tuning up front for everything from Q to operations. Today, another challenge we see when also having 2800 coming in play is a majority of the Q studies that is done today is actually probably based on obsolete technology. Technology and software with pure inverter-based sources is changing way faster than the lead time of a Q study. So how do we ensure throughout a Q study that models, equipment can be updated and better represent what's being installed maybe 2-3 years later? The other thing is here, detailed models, EMT models, PSCAD models doesn't always necessarily mean accurate models. So we would like to look at how can we help form the industry defining accuracy and accurate models instead of only distinguish between WEC, RMS, and EMT, but accurate and representative models. Some of the questions also out there for everyone on the panel or in the workshop here to webinar is, how can we as OEMs help taking more accountability? How can we help provide the right information up front for planning reliability studies? What can we do from a technology improvement? We can help with all the software changes, the new equipment, hardware we are pushing out, actually significant reduced transmission costs, and on top of that also improve grid stability. So how can we as an OEM get more involved up front and more frequently to support the industry, both the GEOs but also the utilities? And then the material modification process. Having studies done today where plants are going to be commissioned 4 or 5 years out, we don't always know the requirements in the future. With some of the material modification process today, how can we better support that and de-risk changing technology and equipment on a site to overall help with reliability, but also help in the renewable journey and adventure we are on here in US with the amount of renewables that has to be integrated. So that's some of the questions and thoughts that we are working on internally here, how we can better help and support the industry on that. Next slide. Yeah, last slide for me. So I'll hand it back over.
Very good presentation. I'm sure there's a bunch of questions in the Q&A for you to get to before we get to the panel questions. So we're going to move right on to Prashant. You may be on mute.
Yeah, can you hear me now?
Yes, I can.
Perfect. Yeah, thanks so much for the opportunity to talk. I'm Prashant Kansal. I lead the power system engineering team at Tesla. We can go to the next slide. And basically, our team is responsible to produce the models and essentially represent our product in the models. And we do that on various platforms. Wherever we can do user-defined, we are doing user-defined. Wherever we have to do generic, we do generic. And then we interface with grid operators worldwide. Ours is a global team, so we just not only provide the models, we also do the studies in some of the regions where Tesla as an OEM can access the grid models, do the full interconnection study in-house. So we see the pain of using the models if there are issues. And as Thomas was mentioning, like models are used all the way from pre-sales to post-commissioning and through the life cycle of the project. So we dearly understand how important it is for the models to be accurate and user-friendly for other teams to use and for the industry to use. Yeah, we can go to the next slide. Yeah, and I think I have some like different variation of the content here, mostly also focusing about what needs to be going in the model. So here is a typical layout of an inverter-based plant, which is a plant controller. It has a inverter, and if you go from left to right, basically plant controller and the battery inverter, and then you have a medium voltage transformers, and then you have a typical GSU. Transformer and meters, and it's just not a meter, it's information that is used for control. So that is important too. And then the grid model, which can be single machine infinite bus representation when you do the model quality test, like for ERCOT, or could be the full grid when you do the full network study. And maybe if you could do the next click. So and each of these boxes are important, like all the way from representing your meter controller and to some extent, a lot of these inverter-based plant are measurement and controls based, which is I think one of the fundamental difference from synchronous machine, which mostly is physics based, but there is a measurement aspect to the controls of the inverter-based plant. So it's important to represent to the best estimate what is the communication and processing delays, because in some cases it might have an impact. We can go to the next slide. And as we all know, like typical plant level control functions for real power control, for reactive power control, or site compensation are all important. And I just want to highlight this through this webinar is like these are really the three buckets of things. If you see that have evolved or in controls in plant controller, and generic models do some of it but not all of it. So and that's where we see some of the differences. And then on top of it, there is frequency watt, ramp limits, things like that, which are not typical for real power, reactive power control. And if you're grid forming inverter, there could be something that plant controller passes down as a reference, which could be as industry is evolving, could be different for different OEMs. But we see this is very typical of a plant controller. And it's important that as the project get kicked off, and this is maybe some of the nuance of the industry, when you are kicking off a project, maybe it's not super clear which controls mode are being used, as we see it, but like in different projects, sometimes it's super clear, sometimes it's not super clear. So there's some things that evolve over the project life cycle, but by the time the studies are submitted, it's important that the right control functions are picked and that aligns with what's needed for the grid, that's aligned with how the overall plant will function. We can go to the next one. And then similarly at the inverter level, you need to select the right controls, and it for Tesla battery, it ranges from for grid following to forming, and for us, like we do many grid forming projects now across the world, and it's not a new technology for us. So it's also important that we we have a lot of experience, how to tune those. So point being, I think again it's the same thing, like when we are starting the project, like sometime we go through this phase of finding out what exactly needs to be there before we submit the study, and it's just a process, and kind of having OEM engagement helps us there to work with developer or consultant or the utility just to make sure that the right settings are tuned, because all these inverters are very tunable. They're software-based controls, and then if the intent of the project is clear, like you can do what you need to. Yeah, I think we could do the next one. So now on the project and the on the product and the project model, that's how we see it. So when we are representing the product in the model, obviously our goal is to make sure every single control setting that impacts the project path system behavior is represented in the model, and all the setting options that can be there are represented so that we can match the product behavior similar to what ERCOT is doing and many other utilities or ISOs doing the work. World is basically they want to check the model matches the product during or post commissioning. And then on the project model side, we see that we obviously have to present balance of plant correctly. You have to choose the settings, and obviously there is dependency on some of the settings based on how the rest of the balance of plant is designed. Especially the protection trip settings need to be coordinated, and we need to make sure that those are correctly represented. And then we are also seeing now more and more region asking for benchmarking. For my time at Tesla, I'm seeing this request increasing in general. And also I'm seeing the request for site to model benchmarking also increasing recently, and that is during commissioning and post commissioning both. Yeah, we can go to the next one. And here are some of the plots. When we produce our models, we do internal hill benchmarking, somewhat like ERCOT UMB report. So we do that for ourselves too. And then we do model to model benchmarking between EMT and RMS models. And once the site is commissioned, depending upon what is the region's request, like in Australia, they have specific processes. In US, we have MOD. So whatever is needed for model to site benchmarking, that is done too. And I completely agree. Like if we want to have a model based grid planning, then we need to have accurate model, or we have to think about some other ways. So yeah, that is something on the next slide we want to discuss. Maybe you can go to the next one. So I think from the industry perspective, I know obviously industry is really into the tech, like into the deep side of this model benchmarking and grid planning and other things are evolving. So I think it's important that as an industry we define what is good benchmarking and kind of use this as a standard thing. If, like for example in US we can have a unified definition of that. And is it same for the product? Is it same for model to model? Is it same for site to model? Similarly, what we have observed is when Tesla participates in providing project-specific modeling, we tend to see that outcome is much better. It helps us speed the interconnection, and then we see since we participated or we developed the project-specific setting, we tend to think that we see less issues through the interconnection. So that's where I feel like having more OEM involvement really helps. I think another thing we see a lot is definition of partial plant behavior. All of the inverter-based site, as you know, are distributed architecture, which is a deviation from a synchronous machine world where you used to have maybe 2 or 3 big generators. But now these inverter-based sites are many boxes, right, within a site, and there is always something about partial site behavior. And I do see that most of the rub during commissioning comes from this aspect of the plant design, which I think is not discussed in standards anywhere else, but I feel it's a critical one to define. And critical one to define so that you see less plant commissioning issues, because some of the times we go into the commissioning without a clear expectation on partial plant behavior. So we are starting to try to de-risk this ourselves by talking to the customer upfront, like what is expected. And sometimes they don't know because they don't know what utility is expecting. And maybe utility has, or the ISO world has is maybe like starting to sync this more, but it's not fully synced that a lot of these sites are sometimes can have some of the site down, and what is the expected behavior, right? So the next one in my mind, which I feel is pretty big, and is the relay and the meter models. Like the meter is used for controls, and the relay models have historically been just not there. And I feel, especially in EMT models, and I just feel that locks the industry into the RTDS or real-time simulation type of platforms, which is not which is maybe required sometime, but should not be the only way to test protection. So I do think industry need to like work on that aspect of it. And I think the last thought I want to leave the group with is we all hear about interconnection studies delay, and like what does it, where does it come from, and what can we do, and is it something that industry can, like, given that a lot of the controls are software based, and can we define the physics that is self-stabilizing controls, and how can we minimize the process, is there a path forward, or use the first principles thinking on, if the modeling is done with somewhat accurate model, like, is it good enough, or is it something defining like a self-stabilizing control that takes out some of the modeling burden good enough? That's really open question, but yeah, I think I can pause here.
Thanks, Prashant. All right. If the rest of the panelists want to throw your camera back on and come off mute, we'll jump into the panel questions. Let me start my video too. All right. I'm going to start with the contentious one, if that's all right. So, at NERC, we have lots of conversations throughout the industry with OEMs and ISOs and others. And what we hear, what we heard a couple times today is that the generic models, standard library models, they do have some serious limitations in representing actual equipment from the OEMs. But we still see, we being NERC and others, we still see that these standard library models are being widely used, even for things like detailed interconnection studies or special studies and things like that. Do y'all have any perspective on what could be behind this kind of discontinuity? We hear from folks that they may have some limitations, but we still see them used pretty widely. So first question is, what do y'all think is driving that? And then the follow-up to that would be, what challenges do you think there are when thinking about innovating further and using higher fidelity or more accurate models? Could be, similar to user-defined models or other higher fidelity. So those are the two questions. Whoever wants it first can go ahead and jump in.
From Vestas' side on the challenges is, and now I'm going to speak a bit more from a Vestas perspective, is we don't see a challenge of having higher fidelity models. We think that's needed to support the industry and us as an OEM as well in the long run. We cannot afford in the industry not being able to capture the issues and have another big event. And I think we as OEMs also have to take our part of accountability on that, and that will drive in internal processes and development on us. But in the end, that we expect that to be needed.
Thank you, John or Prashant.
Yeah, I think on our side, what we see is, I think some of it is driven by the fact that like some ISOs like have processes around generic models, so a developer has to submit that. And in some cases, recently, I'm starting to like see that like ISO asking different models, right, other than PSSC, like TSAT, right, or different DSA tools, right. And in that case, like sometime it makes sense to have generic model, because now you have to replicate the user defined in all the other platform, and that could be sometimes time consuming if you're running short on the interconnection studies timeline already. So that could be another driver, but those two mainly.
Jonathan, do you have any thoughts on that? And that's a hard one for you to answer.
Yeah, well, I think part of our model quality requirements try to make sure that if they do submit a generic model, we're going to make sure that it benchmarks well against PSCAD and it fulfills everything we want to see. Because what I really don't want to see people do is just have this one perfect generic model that they submit over and over again for interconnection studies. It may be completely unrealistic as far as hardware is concerned, but maybe they they just keep it on the shelf and they submit it for an interconnection study, get the interconnection study going, and then they worry about, getting it right later. That, of course, is going to create problems. So by requiring them to submit these plots every time they submit models, and then checking how things change every time they update the models, we can start to ask questions. Hey, how come your model is completely different, and so forth. But yeah, it is a challenge to tackle.
Yeah. All right. So I'm gonna a couple follow-ups. Well, I'm gonna pick on you, Jonathan, first, and I'll pick on the OEM folks later. Sorry. But I think you mentioned it also in your presentation, but I think you mentioned that most or many of the sites, when you did the verification report, there was at least one discrepancy. Do you have I guess two questions, right? Do you have like a broad, like a big bucket, like a broad percentage maybe of ones you found issues in? Is the first question. And then the second question is, what happens then? Like if y'all see a discrepancy, what is the next step?
Yeah, well, I'm a little, I don't have a percentage. I will say a lot, but I wouldn't run out and panic because some of them were probably minor. But there were some that were like, oh, that is a pretty big error. You probably, I'm really glad we caught that now. Probably wish we caught it earlier, but a lot of them were minor. So, but the follow up is they have to submit an updated model. A lot of them actually submitted the updated model with the report, so that we're getting those right away. So it has definitely been a worthwhile effort.
Cool. Yeah, it seems to be helping
Yes.
to shore up those things. Yeah. All right, and I'll pick on the OEMs now, since that's only fair. But what's the biggest challenge from y'all's perspective for providing ongoing model support or site-specific modeling, or figuring out problems that happened in real life, or supplying models for that? What are like the biggest challenges for supporting industry with those types of things?
From our perspective, the biggest challenge is to get people to accept the models. We spent, a bit provocative, maybe more time on arguing why we need to provide accurate models than developing them sometimes. So there's a lot of processes and so forth around it. So we really are eager to help support the process and provide accurate models. So anything we can do, because it as Jonathan said, the earlier we can catch an issue, the better. It's better for the utilities, it's better for the OEMs, and definitely better for the developers.
Thank you. Prashant?
I think our issue is kind of similar. Is mostly about making sure one model is used in the right way. And then I think we end up spending a lot of time in basically working with the industry to get that basically, I would say in some sense teaching like about how to use the model, right? And if the results are not good, how to set it up and things like that. And that's where we have started to do a lot of like project specific model tuning work in-house, and basically give that model for grid interconnection study directly for the network study. So I do think it's mostly the learning curve and the usage of the model, and we're trying to do as much as we can to not have those repeat conversations.
Cool. Thank you very much. All right. Next, any follow-up thoughts on that from anyone?
Yeah, just a follow. I fully agree as well. And I think one of the approaches we are trying to take is when we deliver a model as an OEM, we don't expect the utility to tune it. We expect, to support and so forth, because when we talk IBR, a lot of it is software. It's not just a machine with some physical constants anymore. So it's software thermal limitations that the OEMs are capable of. So we also, again, trying to see how can we help with the tuning, take that in-house and support to help the process, the resource challenges we're all facing in the industry.
Cool. Thank you. Any other follow remainder thoughts on that for the next question? All right. No nodding. All right. Next question. This is kind of it could be positive or negative, just maybe an observation, but we've seen a lot of model accuracy requirements, model quality checks, popping up across the industry. ERCOT had just presented on theirs. Other regions have theirs as well. But the question is, what's the key takeaway or the biggest takeaway as you're navigating this new implementation? Could it, just for example, is it more work for y'all? Is it extra time? Is it causing pain points for any of your other processes? Just I guess those are all negative things. But then positive things. Is it helping de-risk things later on, things like that? So the biggest takeaway when navigating the improved or new model requirements across the U.S.
I can take this. I think, yeah, I mean, generally what ERCOT is doing, I think is really great, because that's a solid guideline of this is how it needs to be, like for model quality report, right, for benchmarking. I think the only other thing in my mind is, and this is not US specific, like in other markets we see like sometimes people saying, hey, accuracy needs to be 1%. And that's just not humanly possible sometimes because of platform differences, So I feel sometimes like that's why defining accuracy bounds really help, because yes, we need to be super accurate, but sometimes there are platform differences. And when you're iterating these things in email and Excel sheet, it's not hours conversation, it's like months, right? And so point being, like, we need to try to be as accurate as we can be, but also like have something defined so that we don't drag into those conversations for a long time and eventually realize it's not as important, right, in that context.
Who's next for the hard question?
Well, I guess I'll just say that it's kind of been a learning process for everyone. I think one thing people have asked us is, how did you implement all these rules and get people to agree to run the MQTs and everything? Because like probably many other places, ERCOT, it's a voting body to accept rules, and generator owners are part of that voting body. So we really sold it as this is going to make the process smoother over the long term. And we tried to put out tools and things to help it. But it is a very big process, and it is taking a lot of time to review. So it is definitely an investment, but definitely worthwhile.
Thanks, Jonathan. Any thoughts on that, Thomas?
Oh, I agree what has been said so far. I don't have much to add.
All right. So we're going to go into the Q&A now. And it looks like the first one is for you, Jonathan. Sorry, picking on you a lot. The question is, is there anything at ERCOT planned or currently in place for post-disturbance model validation? Not only for plants that tripped offline, but just in general, using a disturbance to validate the models of even facilities that rode through?
Yeah, we are. I mean, we are looking at it. Our disturbance and event analysis, we are performing. A lot of this is limited by the measurements we capture, where we have PMUs and what data we could capture. And so that is something we're working through. We're having a lot of conversations, and we're telling people, hey, for example, hey, you need to set your fault recorders to trigger when there's a disturbance, not just when there's the relays trip, for example, so we get more data. But that is an ongoing effort. I don't have more specifics, but yeah.
Thank you, Jonathan. Well, it looks like we made it through the questions, and you all did a great job of answering them in the chat here. So let me just see 1 second if there's anything else that didn't get answered.
I have a good one I go through.
Yeah, go ahead.
There's what will be some of the guidelines to reduce the typical issues we see when coordinating between PSCAD and PSSE model benchmarking? And I think it's a really good question. And also, I think, Prashant, you talked a bit about like when to use the right model, use the right tools, what the differences is. So I don't maybe have the answer on it, but again, I think it's a lot on the OEMs again to help with that and educate and teach. But there's also some working groups out there, Sigre and others, that are trying to streamline things. But I think it's a very good question on it, and I think that it's good to maybe again write some, maybe not only guidelines but also requirements for submittal, so it can be a bit more firm on some of these things. I also think in these regards, sometimes we have to look at usability requirements of models. It's not only about the accuracy, but what are the requirements to make them easy to use for all the stakeholders?
Yeah, good point. Any follow-up thoughts or to that question Thomas read out for Prashant or Jonathan?
And I think I agree. It's kind of if we can distill some of these things as an industry and a guideline, which seems like Sigre is doing some of that, as Thomas mentioned. Like what are you expecting in terms of platform differences? I think it could be really good one for the industry. Yeah.
Cool. Thank you. All right, we got just probably 2 minutes left, so this could be, trying to think of a rapid fire question here we could get. Sorry, we got a follow-up question internally. 1 second.
There's a good one that just came in. Providing block diagrams for user-defined models.
Yeah. That's a contentious topic. We get that question quite a bit. So
yeah,
go ahead.
And I think it's related to debugging. From our perspective, it's the OEMs that have to do the debugging, not the end user. IBRs are getting so highly complicated, and that's why also we see the challenges with generic block diagrams. I will say for Vestas' perspective, we don't internally have block diagrams for any of our control. It's impossible to maintain. We can't use it for development. So it's getting so complex. So we simply don't and can't provide block diagrams. And if we do, they won't be relevant to the user-defined models.
Yeah, and I think that also speaks to maybe the usability part of it too, right? Is
exactly.
Yeah, if the models that get submitted through the interconnection process or otherwise, like through the OEM, through the GO to the ISO, right? If those are accurate and they're parameterized right and they're easy to use, right, there should be hopefully no need for any debugging at the ISO side. So that would help probably simplify a lot of the mismatch and discrepancies too.
Yeah. If you don't find any issues with the model submitted, then there might be something wrong. We want to catch it up front instead of operations.
Yep. Yeah, and I think that's so that'll be it for the questions. But yeah, just to close out on that last point and the rest of the questions is, we've got to make sure that what's being studied is what gets commissioned, and what's in service is what's getting studied. So it's a big circle and a big chicken and the egg, and in realizing that obviously the interconnection process spans a lot of the a long part of the product lifespan, right? So you might be doing things at the beginning of the interconnection process for product that don't exist yet, and how to mitigate those things throughout the process. So I think just in closing, ERCOT provided a great example of model quality tests and verifications, and we got some really good OEM perspective. So I think the message is that we can be hopeful that if we all work together, we'll lump the GOs in there too. None of them are on this panel, but they're facilitating this process as well with these other stakeholders. So if all of them work together, and kind of start from the bottom up, and everyone's on the same page as far as, with the mindset of doing things with reliability in mind, and that includes trying to do the best you can for model accuracy and design accuracy and things like that. Then I think we can make a really big step forward as far as both performance in the field, and matching, capturing things before they happen, and overall model accuracy. So with that, that's probably enough of me speaking today. But with that, yeah, thanks everyone. Thanks panelists for joining. We'll be back here next week, and I forgot what the title is. Next Tuesday at 4, and that webinar is session 7 of special studies, where we're going to talk about EMT studies, special studies, and other kind of special special interconnection type studies. So we'll take all the things you learned so far, and now go into some practical study work type topics. So we'll see you all next week on Tuesday and Thursday, same time. Thanks for joining, and we'll see you then. Thanks.
Yep. Thank you, Dean.